we're still in a little history here. We need to talk about the IT trends, the information technology trends that have enabled the cloud computing. It's still a little bit of history, and you need to know how all this fits together. The first thing is increased parallelism. More and more computer chips, CPUs, bolted together go faster and faster. Well, that's speed. But what we can do is we can line them all up and say, okay, let's divide the task and send it through. So Moore's law says that computing power doubles every 18 months. Now with the multi-core machines, it went much faster for a short period of time, and now it's going about the same pace. That increased parallelism allowed us to divide up the task for one computer and the task for another computer from an operating system standpoint and shove them together. Virtualization is another thing. The more and more processing, storage, bandwidth, any of the delivery mechanisms that are abstracted, we'll talk more about virtualization in a moment, allow us to reapply those resources as they're needed for different computing processing. Remember, we're not talking about one user here. We're talking about hundreds or thousands of users needing 10 to hundreds of servers. So this virtualization allows us to shift things around really quickly. Commodity components, cheaper hardware, easier hardware to deal with, cheaper hard drives, cheaper servers, they all make it, as commodity components, they all make it easy for us to deliver. And then finally, open source software, where we have the freedom to customize and adapt because we can actually control the programming. That allows us to have a proliferation of virtualization software. We'll talk about Ubuntu later on. Now, the last little piece of history that I want to talk about is the confusion. So I say cloud computing and you say, oh, you mean grid technology. Oh, you mean service-oriented architecture. No, those are different things, and we need to define those things. They help us to make cloud computing. They support cloud computing, but they are not cloud computing. So a rose by any other name stinks because it's not really a rose anymore, it's a skunk. So we're going to look at each one of these. Grid computing. Distributed parallel processing across the network. That means that we can assign some of the tasks here and some of the tasks there across the network. All these resources are going to be independent. It may be that your computer at home and my computer at home and his computer at home, well, we're going to use a little bit of that processing. You may have heard of something called SETI. And take a look at SETI and look at SETI. That uses grid computing. That says we've got all of these processing being distributed. It's open standards interfaces, and by the way, with open standards comes the freedom and flexibility. With closed standards, we may coalesce a market. It requires a quality of service. So grid computing says, well, I need this much processing. Can you do it for a short period of time? And it allows all these different computers. Your computer doesn't look like my computer. I've got a Mac, and she's got a PC, and he's got some other kind of computer. I don't know. It's another operating system. And all that's abstracted in grid computing. And then we join these computers together not in a rigid fashion, but in a loose coupling that allows us to say, oh, well, you haven't checked in for a while. Okay, well, I'll go assign that to somebody else. So it allows for failure. And the big thing with grid computing is that we actually have a strong network abstraction, and that's used very well in cloud computing. Platform virtualization. So Steve Herod, the CTO at VMware, I don't think he still is, but he said cloud computing relies on separating your applications from your underlying infrastructure. Now what we need to talk about is what is that application? And in this case, that application is your operating system. Remember, the operating system is just a program, nothing more than that. And if we can abstract that from the hardware, we're in a much better space. Also, the base operating system runs other operating systems. So we have this core operating systems. In the case of VMware, the underlying original operating system was a Linux variant. And what we do is we strip that operating system down to just its core functionality. Probably not a graphical user interface, probably not the ability to do Word, PowerPoint, and Excel. It's just an operating system that's going to run operating systems, and we harden that. So it's stripped down and it's a hardened host. The other piece in here is to talk, in platform virtualization, is to talk about the hypervisor. Now, hypervisor is a term by one vendor. You could say virtual machine monitor if you wanted to be abstract about your virtualization discussion. You're allowed to isolate other operating systems. So if I'm running the Mac OS and you're running the Linux OS, the two won't collide. So we can play nice on the same hardware and we don't interrupt each other, and we can use maybe the network resources together. We can also run multiple types of operating systems. So even if we have a whole bunch of Windows machines, we can also run a whole bunch of Mac operating systems and a whole bunch of Linux machines and a whole bunch of Unix and AIX. So the hypervisor allows us to abstract those applications that are operating systems up above and then apply resources to them. This allows us to increase the utilization of the physical servers, and it allows, and here's a really cool thing, portability of the virtual servers. We can literally move this server that is running from this machine to another machine as it is running. And that's what the hypervisor, robust hypervisors, will allow us to do. What really platform virtualization does is it abstracts the physical machine. So we don't know anything about what physical machine we're running on, and we don't care. Now, web services help us with virtualization, help us with cloud computing, but they really aren't cloud computing. In a lot of cases, when we talk about web services, we talk about the stateless nature of communicating via HTTP. Remember, every time this particular application, say you come to my web server, it's a new conversation every single time. So what we need to do is we need to track state, access control, identity, all of that stuff outside of the HTTP protocol. And you go, well, Dean, what does that have to do with cloud computing? Well, if you're going to move your processing around from machine to machine to machine, you need a way to map every time that you come back and talk to that machine to execute a new process. You need a way to map those credentials correctly and completely. And the web helped get us there. So what we also did was we needed to be able to describe all of this stuff in an abstract way, and that's where XML kicks in. And so we can communicate every single time, and all of the credentialing information is there. A little bit more on web services. We also got to what are called standards-based interfaces. We don't want to have vendor lock-in or vendor control, so we use interfaces that will allow us to get away from a vendor, like SOAP or WSDL or WS Security. All of these tools, these standard interfaces, allow us to communicate with those virtualized cloud computing resources in a secure manner because we can authenticate. Also, the web does a lot of loose coupling, and the web services will allow us to fail and restart, especially since all of that authentication credentialing information is sliding back and forth. And then finally, what we really get out of web services is web software component abstraction. So this little widget that we have right here can run on this machine or that machine or this machine, and it doesn't matter, and we join them all together and say we've got a whole bunch of widgets and here's your website. We do the exact same concept of web abstraction. We do that in cloud. So we abstract maybe a whole operating system or maybe a piece of an operating system to that machine and a piece of it to that machine. Web software component abstraction helped us get to cloud computing today. Now, SOA, Services-Oriented Architecture, is not cloud computing. It says we've got these web services out there, requesters, registry, and service providers that are out there, and we want to organize them, those services, in a reasonable way so that as we grow, this doesn't become, the super connector with 18 different arms and 12 legs. We use all these web services to compose these complex, customizable, distributed applications so that we can distribute them in the cloud. But this abstraction that we create for services being offered to the client allows us to get there. We could even, with SOA, encapsulate legacy applications so that if we're having problems with them, we know that this can't be broken apart. It needs to sit in one place. This stops a lot of the problems that we run into and gives us a lot of interoperability and extensibility of the applications. The web services organization and abstraction allows for cloud computing. Now, I wanted to go back to web application frameworks to talk about the programming frameworks that are helping us today with dynamic websites. Those same concepts are being offered up to cloud computing, and they support most major software languages. We get an abstraction of programming itself. What we can do is we can separate the business logic from the user interface. If you need to actually process an invoice, we can give you your interface here, and the processing of that invoice may require that we talk to accounts payable, accounts receivable, and order entry systems. We can break all those things apart if we want to. We also have unified application programming interfaces and connectivity to databases on the back end. So the abstraction of, I need to submit this order for the database, well, we don't know where the database is, and remember, the database could be in multiple locations. It could be partitioned, or it could be replicated. So by abstracting that, those application frameworks allow us to process data anywhere we want to. And ultimately, the open standards of web application frameworks allow us to not be tied to vendors.